Hello, everybody. Today we are going to start Unit 3, which is solving compound inequalities. So this unit, just so you all know, is going to feel similar to last unit. We're still talking a lot about inequalities, but with a little bit more focus on graphing as opposed to, with a little more focus on solving as opposed to graphing. So get your solving hats out, everybody, and let's start just by remembering the basics of how to do such things. Okay, so just remember, solving an inequality is very similar to solving an equation, right? Other than instead of an equal sign in the middle, there's an inequality sign of some description, a less than, greater than, whatever. And then there's also one special rule having to do with multiplying or dividing by a negative, which we'll see here in just a moment. So let's get rolling here. If I'm looking at A, the first thing I'm going to do if I'm solving this is simplify, right? If you can simplify one side of your equation or inequality, you always should first. So I'm going to distribute my 5 to get 15 minus 5t. And now it's less than or equal to 7 minus t. Then I want to get my t's on the same side. So I'm going to add t here. For inequalities, I almost always try and just keep stuff on the left. It kind of helps sort things out a little bit easier. So I've got 15 minus 4t is less than or equal to 7. Now I'm going to subtract 15 from both sides. I get negative 4t is less than or equal to, that would give me negative 8, which works out well. And if I divide by negative 4, we get that t is ding, 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 ding. Hold up, t is something to 2. T is something to 2. But here's that rule that I was talking about. If you divide or multiply by a negative number with inequalities, you need to flip your inequality symbol. So this was a less than or equal to. It's now going to become a greater than or equal to. So t is greater than or equal to 2. And I kind of ran out of space here. So for the sake of this one, I'm going to graph it up here. And so we've got 2 on our number line, and hopefully this is old news, greater than or equal to. We have a closed dot, and we're going to the right. So you can see right off the bat how this relates to last section. We're still graphing these, but this is your solution. T is greater than or equal to 2, and then we graphed it right there. For this next one, same thing. Let's start by simplifying if we can. So 4x is going to stay 4x is greater than 2 times 3. If we distribute, is going to be 6, plus 2 times 2x is going to be plus 4x. Subtract 4x. Remember, I like to keep my variable on the left with inequalities. And those cancel. And we end up with 0. 4x minus 4x is 0, is greater than 6. Well, just like with an equation, now if we lost our variables, they cancel out, they're gone. We have to ask ourselves, is this a true statement? Well, is 0 greater than 6? Last I checked, it is not. So this would be an example where you get that x lies in the empty set. There is no solution. No solution here. Okay, let's check out this last one here of our basics, just reminding ourselves of the sort of stuff we did in Algebra 1. And same thing, let's start by simplifying. So we've got 2t on our left is less than negative 1/2 times negative 6 is going to be positive 3, and negative 1/2 times negative 4 is going to be plus 2t, so positive 2t, and there we go. Now again, we're going to see we have a similar situation last time. If I subtract 2t from both sides, they cancel it again, and we're left with 0, and this time we have 0 is less than 3. We'll ask yourself this time, is this a true statement? And in this case, you are absolutely correct. In this case, 0 is indeed less than 3, which means in this particular case, x is in the set all real numbers. Okay, all real numbers would be your solution here. And whoopsie, I forgot to graph these because they're pretty basic graphs. That one's just an empty number line, and this one would be a number line that is fully shaded. Fully shaded. All right. Now let's move on to some new stuff. Now we're going to talk about graphing compound inequalities. So compound inequalities are the things that we talked about last unit, right? Your ands and your or statements. So now we're going to talk about how to graph these before we start talking about how to solve these. And I'm going to give you kind of a step-by-step situation here, okay? So the first step is to actually go ahead and solve it. And so in this particular case, right, this is one where hopefully remember, this is essentially an and statement. So we actually want to break this down into its two separate inequalities, right? So we've got 3 is less than 2x plus 5, and 2x plus 5 is less than or equal to 15. So the middle piece belongs in both inequalities, right? You can see we had 3 is less than 2x plus 5, and 2x plus 5 is less than or equal to 15. That middle piece belongs with both, because if you're thinking about this as two inequalities, right? There's one, and here's your other one, right? So it's two different inequalities, and we break it down just like that. And then we can solve these just like we solved the ones above. So let's go ahead and do that. So I'm going to start by flip-flopping this, because again, I like to keep my variables on the left-hand side here. So this is going to become 2x plus 5. And again, remember, when you flip-flop sides of your inequality, you also flip-flop your sign. So it's greater than 3. Subtract the 5, so 2x is going to be greater than negative 2, and divide by 2, x is greater than negative 1. Now let's solve the other one. Subtract the 5, we get 2x is less than or equal to 10. Divide by 2, and we get x is less than or equal to 5. So what we have here is we have x is greater than negative 1, and remember, these types of inequalities are and statements. X is less than or equal to 5. And now we have to actually graph this. And again, this is where the stuff from last unit came in. So if I graph this, I'll do this one in red. Oops. And this one in green. And just because I already had my green out, we'll start with that one. So x is less than or equal to 5. So that's going to be a closed out of 5. Heading to the left. For my red, x is greater than negative 1. It's going to be an open point at negative 1 going to the right. And remember, for an and statement, we're looking for overlap. Well, I have overlap between negative 1 and 5. So that means that my final answer is going to be negative 1 and 5. And we have an open point at negative 1, a closed point at 5, and there you go. So that's step 2, right? We solved it. Step 2 is to graph it. And step 3 is to give a simplified inequality that describes your new graph. A simplified inequality that describes your new graph. So in this case, rather than writing this as x is greater than negative 1 and x is less than or equal to 5, let's write it as a range of values. So this would be negative 1 is less than, x is less than or equal to 5. And that is your solution. That is how we'd write our solution. Okay, and that's why I had you start working on that on your last review, on your last test, is because I knew we would be starting to do that here. So it's important that we can now look at this graph here and be able to tell me, okay, well, that is the equivalent of negative 1 is less than x is less than or equal to 5, right? That is a range of values. So here's the deal. We actually have another kind of better way of solving this one. This first version is tried and true. It will always work for you. However, because we've got something nice and simple, 3 is less than 2x plus 5, let me plug that in too, is less than 2x plus 5 is less than or equal to 15, right? Because on our left side and our right side, it's just numbers. We don't have any variables or anything over there. We can actually solve this in a little bit of a simpler way. And what I mean by that is I can kind of solve both of these things at once. So as I try and isolate my x, well, we're going to take the same steps, right? Just like we did over on the left-hand side, we're still going to subtract 5 first. And the difference is I'm just going to subtract it from both sides at once, and you'll see we end up getting the same thing. So if I subtract 5, I get 3 minus 5 is negative 2. And 15 minus 5 is 10. Okay, and so now what we have left in the middle is 2x. Okay, so I subtracted 5 from both sides. I did 3 minus 5 to get negative 2, 15 minus 5 to get 10, and now I've got just my 2x left in the middle. Now again, divide by 2, and I'm going to do that for both sides. Divide negative 2 by 2 and divide 10 by 2, and we get, well, negative 2 divided by 2 is negative 1, less than, now we're just left with x in the middle, is less than or equal to 10 divided by 2 is 5. And there you go. You end up with the exact same thing, but it's going to take a little less work. So again, When you have only numbers, no variables on the left and right piece of your inequality here, your inequality range, that is when you can solve it like this. We'll actually see one at the end where you're not able to do that, but just know that that's an option for you. It's going to be a little bit simpler that way. Let's take a look at an OR statement. And OR statements are pretty nice with these because at the end of the day, you're really just solving two different inequalities and graphing their solution, and let's see what happens. Okay, so let's solve the first one. We've got 7 minus 2y is less than or equal to 1. So the first thing I'm going to do if I'm trying to isolate my y is subtract the 7. So we get negative 2y is less than or equal to 1 minus 7 is negative 6. And then we're dividing by negative 2. And again, ding, 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 ding. When you divide by a negative or multiply by a negative, you have to flip your inequality sign. This becomes y is greater than or equal to negative 6 divided by 2 is 3. Our other inequality was 3y plus 10 is less than 4 minus y. Well, let's start this one by getting our y's on the same side. So I'm going to add y to both sides. So we get 4y plus 10 is less than 4. Subtract the 10 over, so we get 4y is less than negative 6. And then we divide by 4, right? We divide by 4 to get that y is less than negative 6 over 4, which is really y is less than, that would be negative 3 over 2. And there you go. Okay, so here's the deal. Your solution is just going to be basically this. So don't circle it yet. Let's see what this looks like once we actually graph it, because remember, we solve it, we'll graph, and then we'll write a simplified inequality as our solution. So if I were graphing this, well, 3 is going to go over here, and negative 3 over 2, that's really negative 1.5, so it's going to go over here. And we have, if y is greater than or equal to 3, well, that's closed point on 3, and then to the right. And if y is less than negative 3 over 2, that's going to be an open point here and to the left. Okay, and there you have it. That is your solution. There's nothing special here. It doesn't end up being all real numbers. So let me make this look a little neater. Y is greater than or equal to 3, or y is less than negative 3 over 2. And there you go. All right, last one. Now this is one, notice, kind of like we did up here, where I said, well, if it's just numbers on the left and right side, you can solve it in a kind of simplified fashion here, where you're solving both sides at once, essentially. In this particular case, we can't do that. Okay, we can't do that. So we are going to have to break this down into two separate inequalities. So we're going to have 3w plus 2 is less than 8w minus 9. And remember that middle piece stays common in both of them. And remember, these compound ones are and statements. 8w minus 9 is less than or equal to 4 minus w. And then same idea as up here. We want to solve them both. We'll graph them. We'll see what we get. So if I'm solving this one on the left, again, let's keep it all on the left side. So let's subtract our 8w here. We get negative 5w plus 2 is less than negative 9. Now we'll subtract 2. Subtract 2. We get negative 5w is less than negative 11. And then if we divide by negative 5, ding, 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 we're dividing by a negative. Don't forget to flip your sign, right? We get w is greater than. Now, these are both negative, right? So this is going to be a positive 11 over 5. On over to this one, we're going to get our w's on the same side. So I'm going to add w. We get 9w minus 9 is less than or equal to 4. Add the 9 over, we get 9w. 9w is less than or equal to 4 plus 9 is 13. And now divide by 9. And we get w is less than or equal to 13 ninths. 13 ninths. So these are some goofy numbers, so let's try and think for a second as to where they're going to appear on a number line. Well, 11/5, if you think about it, that's going to be 2 points. Even if you don't know that it's 2.2, you should hopefully be able to say, well, 5 goes into 11 twice and some change, so it's 2 point something. 13 over 9, hopefully you can say, well, 9 only goes into 13 once and then some change, right? So hopefully you can see that if we're graphing these on a number line, I don't need to know what the change is, right? But hopefully I can tell that this number, the 13 ninths, should appear on my number line first. followed by the 11/5. The 11/5 is a larger number. So if I graph this one in red, well, if we're looking at things greater than 11/5, okay, so that's going to be open point and to the right, and then less than or equal to 13/9, that's going to be a closed point and to the left. And now let's remind ourselves, this is an AND statement. Do I have any overlap, which is what I'm looking for with an AND statement? I sure don't. So hopefully we recognize and we remember from last section that your final answer, if there's no overlap, is just going to be an unshaded line, and there is no solution. So that's why we don't circle our answer right after we solve, because a lot of times we'll find, well, once we solve and graph, right, we might come across something like no solution or all real numbers or things of that nature. So that is your solution for that one. And with that, we now have the basics of solving compound inequalities. Remember, solve it first, then graph it, just like we did last unit, and then simplify the inequality into whatever you can simplify it to. But those are your basics of solving compound inequalities. Very nice job.